Hello, thank you for joining me. In this short video, I'm going to demonstrate how to use the Neurite Outgrowth protocol. From the Count Size tab, if I click on the Protocols button, I get the option to browse protocols. So the protocol I'm interested in is in the Cell Biology Advanced collection. Here you see the other collections that are available. The protocol I want is Neurite Outgrowth. So let's click on the Load button, and the protocol loads in the left-hand panel. The dataset I'm going to analyze has been downloaded from the Cell Image library. It has the accession number CCDB6843, and the full reference is shown on screen. Now, this dataset was acquired to develop automated algorithms for analysis of neurite outgrowth in high-content screens of cultured neurons, so it's going to be ideal to demonstrate the Neurite Outgrowth protocol. Here we see the dataset after import into Image-Pro. Here's the composite view showing the two channels. You can use this to adjust the contrast of each channel. Here's the plate view. Notice that there are 4 wells, and in each well there are 25 fields of view. So I'm going to start by choosing a suitable field of view with which to configure my protocol. And I'm going to start with Setup Mode selected. This is important the first time you run through the protocol. I'm going to click on the Sync button, which means that the channels in my dataset are reflected correctly in my protocol. And I'm going to select the correct channel for nuclei and for neurites. So nuclei labeled with DAPI and neurites with GFP. We can click Next Step. Little warning here to tell me that the data collector is going to be reset by my protocol. That's fine. Click OK. In step 2, we're going to segment our nuclei. Now, by default, the option of a threshold segmentation is selected. So I could just adjust this threshold if I wish and continue, but I'm going to choose the smart segmentation option, which I think will be a little bit more effective for these nuclei. And I'm going to zoom in and select a couple of representative nuclei. Then I'm going to change to select the background. And Image-Pro should then correctly segment my nuclei. I think that looks pretty good. So I can apply a range. So here, using the Edit Range tool, I can select the valid range of nuclear sizes. Here you can see I've got some small pieces of debris that I don't want to include. And by raising the minimum valid size, they're now excluded from my analysis. I'll click OK, that looks good. And I'm also applying here split option, which is using boundary shape. And I think everything looks excellent here, so I'm ready to move on to the next step. So we click Next Step. And in step 3, we're going to attempt to segment out the cell bodies. Now you notice that at the top of this step, we have a couple of thresholding options. We can either edit these by directly entering text in the text field, or if we hover the mouse over them, we get a little slider, which is very useful, that allows us to adjust these options. And you can see that the overlay updates on the image as you make your adjustments, so you can see exactly the effect of the changes you're making. I also get the option of editing the range. So here I can select a size threshold, so anything lower than the threshold I'm setting here will be ignored by the protocol. And you can see that the cell bodies are separated so that each gets a nucleus. So I don't really need to use a splitting option, so I'm going to leave that set to none. And then I can move on to the next step. Now move on to step 4, where we attempt to segment the neurites. And here you can see I have 4 different settings in order to try and successfully segment my neurites. And again, I can edit the values of these settings, or if I hover with my cursor over the setting, I see a slider, which allows me to make some gross changes, and I see the effect of these with the overlay on my image. When I'm happy, I hit OK. Image-Pro does a little bit of processing, and we can see where the neurites have been found. Here I have some options, the link and the prune option. So if I set a prune option, anything below the prune size will be ignored, will be removed. And if I set a link option, any gaps smaller than the link, in this case I set 20 pixels, will be joined. So here we can see that with the link option, I've been able to link some of the broken neurites. And then I finish at the results. Here I get various options that I can set, such as whether I want to export my data to Excel or generate a report. And one option that I find very useful is to be able to configure how we're going to display the data collected results. I find the heat map really useful, so here I'm going to select the heat map option. And with that selected, the heat map is displayed, and I need to configure what I want to display in the heat map. So I'm interested in neurite length, and I'm going to summarize them by sum. So we're going to show the sum of neurites in each image. I also find the data collector block really useful. It's a nice way of showing all of the snapshots. We need to hit the read button. That's really important. That means that all of our settings we just made become associated with our protocol, and also save the protocol. I think it's a real rarity that we get the protocol perfect first time on just one image. So here I've selected another image, one in which the nuclei look particularly faint. I've had to stretch the contrast to even see them here. And I'm going to run through the protocol again and perhaps make some edits. So here I'm adding another object representing the nuclei class to improve my segmentation of nuclei. And I also change the range. So I click Edit Range. And I'm just going to raise the minimum valid size. I've also made some changes to my thresholding options here. I think on the first run I didn't quite select all of the cell bodies. This looks better. And I've also made the thresholding of the neurites a bit more sensitive. We were selecting too much before. This looks better. I'm also going to increase the pruning a bit. So now I'm going to resave the protocol. Now I've made my edits. And I'm now ready to run the protocol on the whole plate. So having selected Finish, I'm going to deselect Setup Mode. That means that we're now going to execute the protocol on the active range, and the active range in my case is the whole data set. So as I click Run, we can see that the protocol is running, and I show the task manager here. And I'm showing this clip at 20 times real speed, just to keep it from being boring. And we actually executed the whole thing in just over 2 minutes, so good impressive speed, thanks to the multi-threaded nature of running protocols. Here we see the heat map, and you can see that, well, A1 is where we see the most neurites. And here I can use the block view to review the snapshots of each of the analyzed images. In the data collector, we have an entry for each image that's been analyzed. It's going to be useful to group these. As this is a well-based data set, I'm going to group them not by collection, but by well. So I've selected the group option and chosen to group by well. I'm going to show the sum for each and collapse. And there we can see the sum of neurite length, nuclei count, and endpoints count for each well. Thanks for joining me for this short video. I hope you found it useful. If you have any questions, please contact Media Cybernetics and we'll be happy to help.